So after the break, we're moving on to some different scenarios and some speakers outside of ERG. But staying with Imperial College, Audrey de Nazelle works with the Centre of Environmental Policy. She's interdisciplinary, works across a number of disciplines, including active travel, exposures, health risks, etc. But importantly, she really works very hard with policymakers to translate evidence and science through to policy, both on the UK scale, the local scale, but right through to the European scale, where she works and co-chairs the policy panel in the International Society of Environmental Epidemiology. So Audrey's going to talk about exposure in travel microenvironments. Thank you.
Thank you. Thanks so much for inviting me. I mean, it's a real pleasure to be here to get to listen to everybody's talks, and I'm really looking forward to more of the discussions. It's also a huge honor for me to be here presenting in this program, so thank you. So I was asked to talk about exposures in travel and microenvironments, and I could have taken that onto any potential direction, and hopefully that will fit more or less what you had in mind, but if not, it'll be something different. So I think here we all are acutely aware how, of course, in exposure assessment for epidemiology, we pretty systematically just look at where people live and look at assign air pollution exposures from the people's home address, and we completely ignore people's travel habits and how they get exposed throughout their daily lives in transportation microenvironments. Even though we do know that for most people, the exposure that people get during those transportation periods is probably the peak exposures, the highest exposures they'll encounter throughout their daily activities. Now, in the context of the promotion of active travel, which thankfully is something that's picking up more and more around the world in many cities, we're promoting people to walk and bike, not only because it's an alternative to car use, but more importantly, it's because it's a way for people to integrate physical activity seamlessly into their daily lives. So are we, in fact, encouraging unhealthy behaviors by getting them to walk and bike in the most polluted environments that we encounter every day, or is this a healthy activity? So those are some of the things that I want to talk about today. So with the advent of more wearable or at least portable types of sensors, we've had more and more studies that measure air pollution in different travel modes. So the first thing I want to do is talk a bit about travel mode exposures to air pollution in different travel modes. So a few years ago, there had been enough accumulation of measurement studies that compare travel modes that we could do a systematic analysis and quantify the ratio of exposures in active travel versus other modes. Should I do something about that beep? It's going to annoy everyone. So I did this with some colleagues, this systematic review, and quantify this ratio of walking versus other modes and cycling versus, or actually other modes versus walking and other modes versus cycling, which was also used as part of the WHO's HEAT tool, the Health Impact Assessment tool, to assess impacts of walking and cycling on people's health. So in this study that was done a few years ago, we identified, so there were only enough studies back then in Europe, so the focus was on European studies. And we saw a pretty clear picture when it comes to comparisons with the pedestrians. So the pedestrians, of all the modes that we were able to assess and of all the pollutants we were able to assess, pedestrians were the least exposed, the most protected, as I highlight here for a PM 2.5. So I think it's about an average 40% higher concentration in cars, for example, versus pedestrians. It was a bit less clear cut for cyclists, but cyclists tend to be the second least less exposed. But since then, we've had many more studies, more pollutants, more cities. So we're now updating this analysis with some colleagues in France, the INSERM, l'École Centrale de Lyon. And so we're including more modes, more pollutants, and importantly, we're also including a more advanced statistical framework to quantify those ratios using Bayesian random effects meta-analysis. So in our new paper, a new study, it's ongoing. We haven't, we're writing up the paper yet, so this is the first time it's been presented, a worldwide presentation, very exciting. So we now have 52 papers. Most of them are still in Europe. but closely followed by Asia. And then we only have a handful of papers in Africa, South America, and Australasia. PM2.5 is still the pollutant that's the most studied, but we now have the appearance of nitrogen dioxide with 3 articles that measured nitrogen dioxide. But now let's look directly at what those ratios look like now with this much larger data set. Well, it's a bit more all over the place. The picture is far less clear-cut. So if you look, for example, at the comparison of cars to pedestrians to what? Can I do this? Yeah, it's cars to pedestrians. Only nitrogen dioxide is there now, indicating a higher concentration in cars versus pedestrians, and the other pollutants are clear. Either cars are more exposed, or it's still in the blurry within the 95. So the number 1 is within the credible interval. So far less clear. It's also less clear for cyclists. As you can see here, the cyclists can, and for some pollutants and some modes, are going to be more or less exposed compared to the other modes. So the picture is not obvious. And of course, you can understand why the picture is not obvious. As we've talked, the previous presenters have talked a lot about variations in air pollution and the different types of behaviors of pollutants. And here, I just want to illustrate one of the issues, as this is work that was done as part of the EPSRC project MAGIC. This paper led by Hugh Woodward, who's right here, so you can direct all the questions to him. He's also at the CEP with me. So in this assessment, we did some advanced computational fluid dynamic modeling on a very small road segment of just 400 meters, and then simulated a bunch of pedestrian and cycling exposures to see what kind of variations that we find in terms of assessment of exposures in this short road segment. And what we find is that depending on the side of the road, where you cross the street, where you wait at traffic lights, the exact minute that you leave you depart from the end of the street, all these things matter, and you can see huge variations in exposures depending on all these different factors. So of course, trying to do a study where you can simply say what are the contrasts in different travel modes is never going to be easy when there's such variation even within each mode. So we know that there's contrasts, we know that there's variations, but in fact, and we know that there's peak exposures, but in fact, we might wonder whether it does make any sense to even consider these peak exposures. Do they contribute meaningfully? Because they're yes, peak exposures, but very short amount of time compared to people's everyday activities. So in the PASTA study, EU project, we we followed people throughout 3 different weeks, 3 different seasons of the year, and they wore microthermometers for black carbon, GPS, among other things, and and in 3 different cities. And so in this sample, we saw that people only spend about 7% of their time traveling, and that contributed to a little over 10% of their exposures to black carbon. But then overall, that led to 18% of people's inhalation, so the intake of black carbon. So you start with, yes, not a huge amount of time, but once you've accounted for this inhalation, it might be quite meaningful. So is that meaningful in terms of health? Well, another study that we did previously from the TAPAS study, in the TAPAS study, we also did a combination of geo-tracking and simulation and modeling of air pollution exposure. And in that sample, we had people spend about 6% of their time traveling, and that led to 25 or 24% of people's intake of air pollution that came from transport. So you would think that could be a meaningful exposure in people's daily activities. Does it matter in terms of health? Well, we know from Annette Peters' fantastic case crossover study that there's an increased risk of myocardial infarction following time spent in transport. So we do have some epidemiologic analysis evidence that could be meaningful. And we have a variety of experimental studies that also show meaningful subclinical effects following the types of exposures that you would expect during transportation, peak exposures during transportation events. Is this going back to transportation modes and contrast between transport modes? Do the contrast of the modes matter themselves? Just to show you an example of using a relatively extreme example of contrast between travel modes, we did a measurement study in Barcelona where we saw that the ultrafine particles were practically 3 times higher in cars than they were for pedestrians and cyclists. But that's not all the question. That's not all that matters when it comes to travel modes, because when you're in active travel, when you're walking and cycling, not only do you're physically active, so you have a higher inhalation rate, but also it takes you a different amount of time to get to places. So just to illustrate the potential impacts of these different travel modes, we just simulated the inhalation. We created like a normalization framework so that we looked at what would be somebody's total inhalation of ultrafine particles in this case over a period of 24 hours, given that whether you are a pedestrian, a cyclist, a bus rider, or a car driver. And then once you've accounted for the differences in inhalation rate and exposure time, duration, we saw that pedestrians and cyclists had 50% higher intake of air pollution compared to cars. So again, not a huge amount of time, but even when contrasts show pedestrian and cyclists being very much protected, they still inhale more air pollution. So is that meaningful in terms of health? Going back to the health impacts. So we do know that, of course, air pollution is detrimental to health, but physical activity, on the other hand, is a healthy behavior. So what's the balance overall of the health benefits and risks of of active travel in polluted environments? We did, as part of the PASTA study, the TAPA study, we did an epidemiological analysis of a cohort in Copenhagen, and found that overall the benefits of physical activity outweighed the risks associated with increased air pollution exposure. And we were able to do that because in that cohort there was information on people's walking and cycling habits. The problem is that most cohort studies, at least until recently, didn't have that kind of information. We didn't have very good exposure information, but at least we knew that whether people walked or biked as part of their daily commutes. And so we found a overall beneficial impacts of physical activity that wasn't outweighed by air pollution exposures, although some of the mortality benefits were slightly attenuated. We also did experimental studies, as you see in those pictures, where we put people either cycling or at rest, either high-level air pollution or low-level of air pollution. And in those studies, we also found that the benefits of physical activity seem to outweigh the risks of increased air pollution. Difficult to disentangle effects, but it seemed to be indicating that. But we also know from the Oxford Street study that was done here in London that for older populations, a walk in Hyde Park provided the benefits of the physical activity that you obtained from a walk in Hyde Park were canceled out or diminished when that walk was happening on Oxford Street at a high level of air pollution. So again, the jury is still out. This one was, those experimental studies were for just acute exposures, but what we don't really understand is what happens with on a long-term or medium-long-term basis for those repeated high levels of exposures. We try to get a bit of understanding this with the PASTA study, where we also did some subclinical measurements. And in this case, we found that as black carbon increased, the additional benefits of physical activity on respiratory marker, FEV1, decreased. Now, we didn't reach quite statistical significance, but there does seem to be a trend of decrease and potentially even negative impacts on FEV at higher levels of air pollution and of physical activity. So the jury is still out. It still needs to be investigated. all of these exposure contrasts that we try to derive from the measurement studies were then used to be able to develop health impact assessment studies, for example, using that WHO HEAT tool. So we did a lot of different health impact assessment studies, and I just wanted to show you one of the later ones that we've just done that looked at the impacts of shifting 50% of car travel in London onto walking, cycling, and public transportation. And what we see here is the number of deaths avoided, and that's your y-axis, from either walking or cycling. Those are the two columns. And in red is the physical activity benefit, so number of deaths avoided thanks to additional physical activity. And in blue are the trade-offs, and in this case, we're looking both at car crashes and inhalation of deaths, inhalation of air pollutants. So we see that at a population level, when you simulate these behaviors through health impact assessment studies, clearly we have much larger benefits compared to the risk. But again, this is modeling studies at a population level, and I'm going to go slightly off-piste just because I think it's important to point out that there are also multiple other types of benefits when you increase walking and cycling and when you create those modal shifts. So yes, we have the health physical activity benefits, but we also, the general population benefits from decreases in air pollution when you reduce car use. You also have a reduction in noise and the health benefits of reduction in noise. And then if you think about replacing each of the cars that are currently parked in this scenario and replacing them with a tree, then you also get green space exposure benefits. So there are multiple types of other benefits that I think are absolutely essential to keep in mind when we consider this concept of promotion of active travel. I just wanted to end with this study coming back to air pollution and different travel modes. Again, part of the PASTA study, we were interested in looking at stress. We measured stress as part of using galvanic skin response using this body media senseware. And what we found is that the impacts of air pollution varied. They were different according to the mode you used on their impact on stress. So we saw that for pedestrians and cyclists, as air pollution increased, that statistically significantly increased the stress level of pedestrians and cyclists, but it had no impact on car drivers. We did account for green space and for the type of road infrastructure, but we didn't account for the amount of traffic, so it could be a proxy for traffic, of course. A lot to unpack here, and hopefully there'll be a few questions on this. Just to end, so we've seen that exposure in travel and microenvironments can be quite high. We saw that, of course, there's some potential opportunities for improving health benefits through the promotion of active travel, but there certainly needs to be a lot more to be done to understand and measure or model exposures of people in different travel microenvironments as part of their daily activities to understand the health impacts. Thank you.